Okay, so earlier I told you that the derivative of the tangent of x is secant squared x, okay? But why, all right? So I want to show you why that's the case. So let's look at it. If we had the function, y equals the tangent of x, and I asked you to get the derivative, okay? You would say, well, it's secant squared x, because that's what you told me, but I want you to understand why, so let's think about this. What is tangent of x? It's sine over cosine, right? So sine x over cosine x. That's a quotient, okay? So we could use the quotient rule to show that the derivative of the tangent of x is actually secant squared x. So let's take a look at that. Okay, so remember the quotient rule? I talked about have your numerator be your f of x, your denominator be your g of x. So f of x equals sine x. And now we need to get the derivative, so f prime of x. So the derivative of sine x we talked about is cosine x. And then your g of x is cosine x. So the derivative of cosine of x is negative sine x. Okay? So again, with the quotient rule, it's going to be that times that minus that times that over that squared. So we've got cosine x times the cosine of x minus sine x times negative sine x over cosine of x squared. Okay, so now we're going to come up here with this, and that's going to be cosine squared x. Then minus sine x times negative sine x, that's going to actually be plus sine squared x. Over, and then that's cosine squared x. Oh my goodness. Remember from last year that cosine squared x plus sine squared x is a trig identity, and that actually equals 1. So we can replace that numerator with 1 over cosine squared x. And now look at that. 1 over cosine squared x is just secant squared x. So our derivative would be secant squared x. Okay? So there you go. Pretty cool.